Hey, good morning, Sumit on this side. This is going to be a very exciting episode. I'm going to show how I've recently prompted a fairly highly technically detailed task. I went from the broad idea. This is based on top of an existing project that I'm doing, and I'm building an SDK. So the project is about building an SDK, software development kit. What it will do is it will allow me, as well as other consumers, anybody who wants to integrate to large language models, LLMs, to use this library within either Rust or any other projects made in PHP, Python, Ruby, Node.js, etc. Because I'm going to create adapters for all of these other languages to be able to query or communicate with any large language model, any LLM. So I'm starting with a opinionated set of LLMs, which I feel are very necessary in my daily flows, and they have been working out really well. So I'm going to focus on those, and then of course the adapters around them, multiple providers in some cases. For example, Grok Code Fast One, a particular model, is available both through Zen. Zen is a model selected curated set of models offered by open code. They are running this as a service themselves, and the same model Grok Code Fast One is also available directly from XAI, which is XAI as in x.com, Twitter, etc. So sometimes I need to handle these multiple providers for the same model. Of course, for example, as you already know, some of the popular models like Claude Sonnet, for example, is available both on officially on Anthropic as well as on these other cloud providers. So AWS, Bedrock, Google Cloud, Microsoft Azure, Foundry, etc., etc. So how do we handle those kind of things? So what I'm going to talk about is a related prompt that I have done, a related feature that I have done, which is addition of tool calling or function calling. So tool calling and function calling, just for the uninitiated, is the feature where you have your own tool. Let's say you've created a weather tool, you've created a database read tool, or an API reader tool, etc., web search tool, etc. And you give this model, any model, the choice, any model that supports tool calling, the choice to call a tool whenever the model feels like. So let's say the user is asking for weather information, and you want, like, yeah, okay, the tool is available. If you want to go ahead, use it. So the model will decide, and depending on the situation, the model can call the tool. So that's what tool calling broadly is. I'm adding tool calling, of course, to my product, to my library, this library that I'm creating, which allows people to use multiple models. But we're going to focus on the process to get there, not on the tool calling, not on the feature, but how did I prompt, how did I go there. So let's dive straight into the prompt. So I'm going to show you, first of all, I'm going to show you what did I do with Claude. For example, this was the starting prompt. I already had this library. I'm already building it. It's already kind of halfway there, or maybe the early 10-15% is already there. I wanted to add on top of it. So first of all, I have a task document, which was the initial creation of this SDK, this library. And this is the high level task document. Remember, everything I'm showing is actually generated by AI. All the code, all the documents, everything is generated by AI. Only the prompts are mine. And those I'm going to show you directly inside either Claude Code or Open Code, because that's the primary tools that I use. In Open Code, I primarily use either GLM 4.6 or Grok Code Fast One, and in Claude, I use Claude Sonnet. Now, when it comes to the high level specification, the task, I call them the task. The research documents are a bit different, and there are external documentation which I download sometimes. For example, the API documentation of a particular provider that I'm integrating, those are separate. So there are different kinds of documents we're talking about, just to keep that clear. This is the high level project specification or the feature specification of this module, this library that I'm creating. As you can see, this is nicely laid out and it's created by AI. My initial prompt for this was just my idea, the dump of my idea. That prompt is somewhere a little back in the history, so I'm not going to dig it up. But what we're going to do is, how did I add this extra feature on top of this library? So what is the initial prompt for that? So let's go back. Let's see. This is the one. Okay. So I say that please read, and this is exactly how I prompt. This very, very human-like language. There's nothing fancy about it. Please read the tasks document, this document that I'm showing you, and the other document, which is add Zen provider support. So I have another document here. I can show you add Zen provider support. Both of these documents, I simply mention it to the agent, in this case Claude Code. As you can see, I'm inside Claude Code. We now have support for multiple providers for the same model. As you can see here, we now have multiple support for multiple providers. So basically, like I said, the Zen is one provider, but the model is still Grok Code Fast One. You can access it via Zen, or you can access it directly through XAI. Okay, so multiple providers for the same model. Now I'm asking, should we tackle tool or function calling? Please analyze. In the analysis, it showed me a bunch of things. It showed me a lot of details. I don't think I can show you that because that's in the history. The outputs were not logged. Some outputs were logged, and I'm going to show you which ones were logged. But this particular output was not. What it did was is it looked through the situation of the particular SDK, the library that I'm building, and it figured out that yes, tool calling does make a lot of sense, and gave me 3 options for the tool calling. So it says in Rust, there's this one way, there's the second way, there's the third way. Okay, so it gave me 3 options, and I thought, okay, first of all, I don't want such options. I will decide on those options, but the final task document, I do not want to have options, because you want the final task document which you want to hand over to a coding agent to be as clear and precise as possible. No giving options. Okay, so options are in the planning phase. You figure out the options, you do your research, and then you simply go ahead and choose one of them, and finally converge into one that you believe that will work for you, your solution. Okay, so it gave me those options. Then I asked for the next prompt, which is where I'll show you there are some documents it created. So before we start, since this is an SDK, how would a consumer send this tools list? Now remember, we are adding tool calling, function calling feature, right? Which means that the weather tool, the SQL tool, maybe API tool, etc. These are your tools. If you are a consumer of my library, these are your tools. You will be providing the set of tools which are going to go to the model, which means I do not provide the set of tools. Maybe I have some basic tools. Web search maybe is already built into the library. That's fine. That's great. But I want people to be able to give their own tools, which means that the set of tools in a proper format, typed as much as possible, should be coming from the consumer. The consumer here is the consumer of the SDK, not necessarily like an actual consumer out on the street. I don't mean that kind of a consumer. I mean the consumer of the SDK of this library. So as you can see, I'm drilling down into some of the specifications. It gave me more output. Okay, again, that output is not saved. Unfortunately, I cannot show you that. But here is where things get stored in documents. It stored them automatically, by the way, because it has also scanned my repository. It has seen that I create a lot of documents around this planning. So it started saving them, and we can show you those. So I asked, because I know that I'm going to create adapters for this library with Python, Ruby, JavaScript, PHP, etc., which means that I want this to be also thought through. Like, okay, how would that other foreign programming language won't interact with the Rust, library that I'm building? So that's, by the way, where this term called FFI comes in. FFI is foreign function interface. That's how you have features from one programming language that can interoperate with features from another programming language. So that's just a common pattern. Even though I've never worked with this is the interesting part here. I have never worked with foreign function interface. I've never really built these libraries in this way. So I do not know. I just know the term. I just glanced at the overall documentation. Of course, I'm being an engineer. I know what it is supposed to mean, but I do not have professional experience, which is still fine. Because now what I'm doing is I'm looking at the architectural documentation, the comparisons that will create. You will see that it will create a bunch. So I asked it, could we refer to existing Rust? And this is where the references start. And let me show you the references. So it created a bunch of these documents. So first of all, polyglot SDK design and real world FFI examples. Okay, these two are important because these two are basically references. So if you look at the real world FFI examples, you'll see that it is referred to actual examples of projects where there is a Rust core, okay, and there is some kind of a Python. So for example, this one is Polars. Polars is Polars being from Rust. Polars is a library for data processing, and there the core is written in Rust. And then they have the Python module, they have the Node.js module, and then they have the R bindings also. R, the programming language R, and the core is still in Rust. So almost all the business logic is done in the Rust core, and then they have these thin wrappers on top which are for different programming languages. It gave me a very nice description of it. It says how we should adapt some of this thinking process. Then it looked at Ruf. Ruf is the tooling for Python, which is written in Rust. So this is the linter, formatter, etc., that is written in actually Rust, but is available in Python as Python tooling. Again, it scans it, figures out how it relates to what I am trying to solve, and gives me a summary. Then it goes to cryptography libraries. Then it goes to I think the next one is data fusion. I don't really know what data fusion is, but again, this is exactly what I'm trying to tell you, is that you don't need to know all the details. You need to skim through what is important to you, and then I just go over step by step, and then you'll finally see like how I converge them into a task document. Anyway, so let's first go through this document. So we see, okay, it has given a lot of lessons, learnings, etc., approaches, and then it did a comparison, showed me some extra code. This is the specific Rust library, the schemas library, which allows basically to have a type definition of how you would talk with JSON and Rust, etc. And this is primarily going to be the way that other languages will define their structures, and they will be converted to the Rust structure and then finally sent to the model as JSON. Because of course, at the end of the day, you need a schema JSON generated out of your code to be going to the model. The models directly don't talk in Rust. Okay. And that's about it. So this document, and then the other document is about the polyglot SDK design. This is polyglot simply because there are multiple programming languages involved, the core being in Rust, and then these other adapters created for the other programming languages. It gave me a very high level documentation, gave me example code, different languages. So these two documents are related, as you can understand. And then finally, it also created a design document. This is technical design, and the final decision. So this decision is after I said that, okay, so what are all the choices, pros and cons, blah, blah, blah. It created the design document, and then it created the decision document where it gave me, I believe, hang on, I'll just have to find it. I believe there are, so the phases are here, like the Python bindings, first the Rust part, right? And then we'll create Python bindings, etc. But I believe somewhere, maybe I don't have it right here, or maybe it's not in my memory where it is in these documents. But it also gave me choices as to how the Rust core will be implemented. There were two choices, or maybe three even. Finally, what I did was I went ahead and I said, okay, I read all of this. Let's see that prompt. I said, let's create a task. This is how I do. I converge all of that back into a task, because I'm going to hand over the task to the next coding model. And you'll see that is that when I do this, I do not want this extra baggage, this extra research to be done. That has been done, that has been done to be part of that task, because the task, as compact as you can make it, the better it is. So what I'm saying is that let's create a task for this. In the tasks folder, I have a task folder which you've already seen. Please include the derive based approach. So this is where it had given me 3 approaches. I took the derive based approach after studying and understanding, like, just at a high level, does it fit to my needs or not, and mention the future multi-language features that we need. Okay, so of course we will expand other languages, like I said, Python, Rust, Ruby, PHP, Node.js, etc. Blah blah blah. And then share the technical context and examples, but do not link to the other documents which we created for our research. This is where I keep the context very compact. Okay, so let's look at the final. This is the final task. It created this final task as something that I could hand over. As you can see, this is comprehensive and lengthy enough, right? It has example code, it has a very high level description. This talks about what should be implemented per also language, by the way, what are the language level features. So for example, Claude already supports server side tools. For it has web search tool, bash tool, etc. It can execute code on Claude's infrastructure, etc. Those are already been mentioned, those have already been mentioned, which is great. And some of these allow the code to be generated in the way that I'm thinking through also the features in the near term. I'm thinking through those future term features, which is adding the other language bindings, and what is to be tackled right now, immediately. Okay, so what tests to be generated. Now let's look at the code, and then finally we'll look at what I actually sent to the coding agent. The coding agent in my case is OpenCode. I use OpenCode with Grok or with GLM 4.6 simply because I reduce the cost that way. The actual token cost of output tokens is higher than input tokens. So I do the research, which is a lot of input tokens, collect data from the web, research, find documents, pull it all in, make multiple documents out of those research. I will look into them, then finally create a task. The end of this, so think of it as a funnel. The input is it is a lot, right? It is going to research through all my local files, existing code, blah, 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 research documents online, blah, 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 create new documents, and then finally funnel it into one task document, which is what is this. But on the other side, on the coding model side, by the way, the actual coding is to be done. This document actually expands into multiple files because it is going to code, right? And when you code, you probably end up, depending, of course, depends on the feature, by the way. Sometimes you're just fixing a bug and maybe it's a one-line fix. But sometimes, like in this case, it has edited so many files. As you can see on the right-hand side bar, it has edited so many files. This is open code because that's how I keep the costs low. There's another reason for this is because sometimes the coding is not good enough, or maybe something is just not done properly, or I go testing and something is broken, etc., etc. Like for example, there are also tests written in this which I can run for you, and you will see that these are very comprehensive tests. Will show the actual test results, the actual test code. And there are also integration tests, which means it makes actual API calls to the Claude model or the other models, and expect some responses from the models. It's very comprehensive, very thorough. Even hello world is fine sometimes, but sometimes more than that. And in the case of tool calling, for example, I expect it to make an actual request like, hey, find whether the information here is my tool, whether tool, are you calling my tool or not? So that level of comprehensive test is all there. And this is all AI generated. Like I said from the beginning of the video, this is all AI generated. I do not write the lines of code anymore. I sometimes review a little bit, tiny bit, but most of the times I'm just spending time on the planning. That's how I'm getting the time to do, for example, recording this video, right? Let's look at the generated code. Like I said, let's go into this. We'll see that it has created a separate tools module. Okay, I'm not going to go line by line into this file. What I'm going to look at is first the tools integration, the calling. Okay, so this is where I expected like there would be a test which creates a dummy tool, sends it to the model along with a prompt, and it does that. So there's a weather tool. I see it has created a weather tool. It has asked for temperature unit, Celsius or Fahrenheit, etc. Blah blah blah. Get current weather for a location. This is basically this what this weather tool is supposed to do. This takes these parameters which are described above as you saw, and then the actual prompt is what is the weather in Tokyo. So I'm expecting that it will call the tool with some parameters. So the parameter probably has a location, which is the city name, Tokyo, right? And the text output, sorry, the test validation is in that the output should have Tokyo, because it should be calling the tool with the parameter Tokyo as the first parameter, okay? And it's going to send a fake result. Of course, this temperature is fake. It's going to send a fake result to the model, and then finally the whole model to this agent, communication, this library communication should end. So it does all of those checks. It checks that the model has asked for this tool get weather. It has given the correct parameter, which is Tokyo, and then finally it sees that the interaction has stopped. This is a fairly comprehensive test. Again, remember all of these lines. You can, by the way, add bundles of more tests. You can add more fancy features. You can add tests which have multi-step, chats, for example, is just by requirement. Maybe you've thought through something more complicated. You can do all of those. And the beauty of all of this is that you are spending time, like I'm spending time in the planning mode. I'm not spending time in the coding mode. And definitely not in the review. So review also I get done by Claude. So I'll have open code which did this. The prompt that I sent to open code is actually very simple. It's by the way not visible here because of the color setting, but this is the prompt. Please attempt task/task. That's it. Okay, that's what it takes to get all this code generated. Now I'll show you the git diff. With the git diff, you will see how much code we changed. Okay, sorry, not git diff. We can just do git status, and that should be good enough. Okay, so this is all the code that is generated or changed, right, per model. As you can see, inside Grok, inside OpenAI, inside this, inside Claude, all of this of course had to slightly change because of this tool calling functionality, right? Little bits of change in all these files, not a lot maybe, but little bits in all these files. And then some major changes has happened. Of course, all the tool calling related, these are completely newly written files. So as you can see, it's a comprehensive feature done. I didn't write the code. I didn't even review the code. Here is how I review. I simply go to Claude. Can I show it to you here? Well, I can run this for you. Okay, so this was the final prompt, and I'll run this for you again. We worked on task/the task path, right? Please review the work, and done. That's it. I just sit back, relax, get the review done. We'll see what Claude says. I'm not going to continue this, by the way, because I've already continued. I've finished this episode. I've already done this, not this episode, this task. I've already reviewed, etc. And so I know what was the outcome. The outcome was pretty good according to Claude. It was nicely done. It did give me a few suggestions, so I can look into them later. What I can do is probably save them as another task and then look at it in the future some other time when I have the time. But this hopefully gives you a very clear idea of how I prompt, going from a very high level detail, creating research documents, references from the web, finding, in fact, I go into dig into existing other open source software which I find relatable, right? As long as the license permits, etc., those checks you can do for yourself. And then finally creating one document, one task, which I say, which is get this job done. Then hand it over to a coding model. Another, in my case, it's a different coding agent and a different coding model, simply because of my cost factor. So I use the pro plan with Claude, nothing else, nothing more. So just $20 a month plus taxes. And then I have the GLM subscription. And then for Grok, I have a credit account. That's it. Very simple. I'm not spending hundreds of dollars, and this entire project on GitHub is available. You can check it for yourself. More than 42,000 lines of Rust at this moment, I would say. Mostly works. Other than large like planning level issues, it does not. Of course, it's written in Rust, so it does have the benefit of that strict checking by the compiler. But generally speaking, it does not have glaring mistakes. Okay. It does have planning level problems, which you can imagine like can happen for any engineer, any product manager, whoever you are. But that's mostly thinking through the features. Like, okay, I did it this way, but it should have been that way, right? Other than that, I would say it's been a fairly fun ride. I'm happy to share more of these things. If you have questions, please reach out to me. I'm available. You can reach out to me on Twitter. You can reach out to me on LinkedIn, wherever you want to, and then I'm happy to answer your questions. Have fun.